look, it's Nia.
Hey!
Hi, I'm with Vogue.
Hi. Are you here to talk about my new Mrs. Chen movie?
Yes.
Yes. Okay, so the newest upcoming Mrs. Chen movie is about the 7 forms of energy.
Are these two girls in the movie?
Yes. This is Emily in the red and Elliana in the blue. They are demonstrating potential and kinetic energy.
What's potential energy?
Potential energy is the energy stored in an object.
What's kinetic energy?
Kinetic energy is the energy an object has while it's in motion.
Can y'all represent that for me?
Yes. When the ball is at its highest point, it has the most mass it can have and the highest height it can have. So therefore, it has the most potential energy. And whenever it's at its lowest point, when it doesn't touch the ground, it has its most kinetic energy.
Is that all the energy you're representing?
No. We are also representing mechanical energy.
Yes.
Mechanical.
When their arms move to hit the ball, that is mechanical energy.
Why?
Because we're moving parts of a system.
Okay, thank you. How was you guys' day?
It was awesome.
Okay, I noticed the sun's going down. That's such a pretty sunset.
Oh yeah, when the sun is a type of radiant energy.
Why is that?
The nuclear energy in the sun is converted to radiant energy.
Is that also light?
Yes.
Yes.
And radiant energy can be used to convert electricity.
Why don't we go inside? This is Madison, Elliana, and Jasmine.
That's some good music.
Isn't that sound energy?
Yeah, sound energy is the energy produced by vibrating particles through sound waves. Elliana's teaching Madison how to play the piano. So, since Mrs. Chen represents something, what does the C stand for?
That's easy. The C stands for chemical energy. The cast is eating pizza, which is a form of chemical energy.
Chemical energy is the energy after a chemical reaction.
Cool. It's stored in chemical bonds and it relates to food because food releases chemical energy during digestion. Like the pizza, right? Okay.
Let's go see what me and Madison are doing.
Okay.
What are you guys making? Tea! Ow, that's hot! Don't touch it! Why is it so hot? Let me tell you why. The H in Mrs. Chen stands for heat energy, also known as thermal energy. Thermal energy is the total amount of kinetic energy in the particles in a material. The oven burner is hot and the kettle is on top of it, so the oven is transferring its heat to the kettle. Wait, isn't that called conduction? Yeah. There's these little swirling things that go like this, and they're heating up the water.
Aren't those called convection currents?
Yes! So, the water's starting to boil.
Oh yeah, why is it making that noise?
That's because when the particles are being heated up, they're moving faster and farther apart, which causes the steam, which is why it's making that noise. What tea are we making again? Rope coat. Rope coat! Oh, that sounds good.
So in this segment, we will be learning about.
Well, how have you been answering my calls?
My phone's not turning on. Well, have you checked the battery level? That's a good idea. Let's look. My battery is gone.
Where did
How
it
many
go?
times have you lost your battery?
I found it!
Probably a bunch, but why was it in your goggles?
She likes batteries.
Well, that's understandable because, you know, the chemical energy of the battery transforms to electrical energy.
What's electrical energy?
Electrical energy is the energy of moving electrical charges.
Whoa, that's cool.
Yeah, and now I can turn my phone on.
So I can ride those electrical waves?
I see a reflection.
Oh,
Hello, I'm
hi.
from Vogue. In
Yeah.
the bathroom.
That's nice.
Are you reading any books right now?
I'm reading The Da Vinci Code by Dan Brown.
Are your friends from the movies reading any books right now?
Looks like it. Let's ask.
Oh yeah.
What are you reading?
We're reading 1,000 Paper Cranes.
It's a good book.
Yeah, it's about this girl named Sadako Sasaki, and she gets the atomic bomb disease. So
Isn't that nuclear energy?
pretty much a atomic bomb? What's it called? No, a nuclear bomb explodes, and she gets a disease from radiation. I think I'm not that far into the book, only on page 2.
So what's nuclear energy?
Nuclear energy is energy stored in the nucleus of an atom.
It can be released by either fusion, which is when the two atoms join together, or fission, when the atom is split. And when an atomic bomb is dropped, the atom is split.
Split.
Okay, so the wind in our hair, I mean, you can't really see it now, but there was wind, and wind is a form of a renewable resource, which is a renewable resource is, Nia, help me out.
A renewable resource is a resource that cannot be used up.
Okay, so wind has many benefits, like
It produces clean energy and it doesn't use up the fossil fuels, which are non-renewable resources.
however, using renewable resources is very expensive. Oh yeah, see, now you can see it, okay. So yeah, I think that's it. We'll add anything else. Okay, bye. Okay, say bye.
Bye.
There are also non-renewable resources, and non-renewable resources are energy resources that we can run out of.
Some examples of non-renewable resources are coal, oil, and gas.
Hey Nia, what's this?
Whoa.
Oh, that's cool. What is that?
What's it called?
A Newton's cradle.
Oh.
That's really cool. Why was it moving back and forth?
Oh, that's because when I put it up, it builds up potential energy. Then when I release it, it transforms it into kinetic energy. This ball transfers the energy through those balls and then ends up over here, which makes that one go up.
Cool. Why does it do that?
This is because of the law of conservation of energy.
What's the law of conservation of energy?
The law of conservation of energy states that you cannot create nor destroy energy. So as the ball hits the other balls, it is not created nor destroyed. It is from potential energy, creating it into kinetic energy into the other ball.
Cool.
It was a dark and stormy night, and there were 5 girls. And they came out, walked downstairs, and when they looked over, BAM! Their parents were making fried chicken! The end.
Hey, I wonder how the flashlight worked.
Oh, that's easy. The chemical energy in the battery of the flashlight is converted to electrical energy, which is converted to radiant energy, which produces the light.
That's cool.
This is a molecule. Just lit a fire in the other room and is heating the air in convection currents. We will show you how the molecule moves.
The air starts at the bottom and begins to rise with the heat.
This is because an increase in thermal energy and differences in density.
When the air reaches the top, it starts to cool and then it condenses.
And then it starts over.
And this process keeps going until
The temperatures are the same.
This is called heat transfer.
Heat transfer is the transfer of heat to other objects.
Pop it up to like.
Let's make some toast.
how does the toaster work?
Well, whenever we push the toast into the toaster, the electrical energy transforms into thermal energy to cook the toast into toast.
Hey, now it's chemical energy.
Yeah, after she eats it.
That's some good chemical energy.
So, are you guys ready to leave?
Yeah. Okay.
So that's a wrap, I guess.
Oh wait,
Yeah.
we need to turn off the TV and lights.
Oh, yeah.
Oh,
You're right.
Yeah. we don't want to use up all our non-renewable resources.
We save more energy.
Yeah.
I'll see you guys tomorrow.
Bye. Bye. Potential energy is the energy stored in an object, and kinetic energy is the energy of movement in particles. So, because potential energy depends on the mass and height of an object, the roller coaster cart has the most potential energy up here at its highest point. And as it goes down, it increases in kinetic energy because the potential energy is being transferred to kinetic. And the potential energy slowly decreases. And at this point, right before it stops moving, there's the most kinetic energy, because kinetic energy depends on mass and speed of an object. And as it comes to a stop, the kinetic energy is transformed back to potential energy.
We're going to talk about the 7 forms of energy, which is Mrs. Chen. The M stands for mechanical energy, which is the movement of objects. The R stands for radiant energy, which travels through electromagnetic waves. The S stands for sound energy, which is released by vibrations of particles. C stands for chemical energy, which is released by chemical. The H stands for heat energy, which another word is thermal energy, and it's the sum of kinetic energy. The E stands for electrical energy, which is the moving of electrical charges, and the N stands for nuclear energy. This process is done by fusion, the fusing of atoms, and fission, the splitting of atoms, and it happens in the nucleus.
Okay, so the law of conservation of energy says that energy cannot be created nor destroyed, it only changes form. And so if we had this guy that was 10 stories up and he was trying to drop an egg for like a science experiment or something, it would start off with 100 joules of potential energy, because potential energy relies on mass and height. And so yeah, it would have 100 there, and then as it drops, its potential energy slowly changes form into kinetic energy. So that's why halfway down it would have 50 joules of potential and 50 joules of kinetic. And then after it lands on its head, it would have 0 joules of potential, but it would still have 100 joules of kinetic, because you never lose energy. Oh! I missed.
Energy transformations is the changing of energy from one form to another. So, for example, a biker. The chemical energy from the food the biker ate is transformed to mechanical energy as they move their legs, and that mechanical energy is transferred to the bike as she pedals, and it helps her move. So, yeah.
So, these are our energy resources, and we use them to produce electricity to our homes. So in the non-renewable category, we have coal, natural gas, and oil. And we use these fossil fuels faster than they can be replenished. Nuclear is also in this, it's just not here. Over here in the renewable category, we have solar energy, biomass, wind energy, tidal energy, and geothermal energy, and they never run out.
Hey, why do we have the heater on and the fan on?
We shouldn't. That's a waste of fossil fuels.
Oh yeah, okay, what the hell is that?
We need to conserve the energy so we don't run out of fossil fuels. Anyway, heat transfer is the transfer of thermal energy from one object to another. There are 3 types of heat transfer. Conduction, which is the heat transfer through direct contact. Convection, which is the heat transfer through convection currents, which is pretty much the circulation of air throughout the room. And then radiation, which is the heat given off by an object like the sun or a flame. Thank you for watching Behind the Scenes with Mrs. Chen.
The movie will be out this Friday.
Go check it out.
Bye.
Bye. Let's go see what Nia and Madison are doing.
Okay.
What are you guys doing?
I'm making tea.
start?
So, what?
Oh, I got that on video.